This is part 2 of the review on simple harmonic motion. In this partial question, we have a mass that hangs vertically from a fixed point by means of a spring, as shown in figure 4.1. The mass is displaced vertically and then released. The subsequent oscillations of the spring are simple harmonic. The variation with time t of the length L of the spring is shown in figure 4.2. You must understand that you must match the points A, B, C, D, E, F, and G on diagram 4.1 with the point A, B, C, D, E, F, G in diagram 4.2. The reason why this point is A is because you can see that A is at the lowest position where L is the biggest. You can see that L is increasing in this direction. So the object is moving from A to B. Then from B, we move to C, then back to D, go down to E before it rises again to F, and then reaches G. So the object is stationary at B. So the object is stationary at A and E, C and G. But the object is moving up at B and F and going down at D and this point here. So you have to use figure 4.2 to state two values of t at which the mass is moving downward at maximum speed. When you do this question here, you must remember that this object undergoing simple harmonic motion is moving the fastest at the mean position. And then at the mean position, the acceleration is 0. They always test you on this concept. So the two positions where the object is moving downward maximum speed is at D and the point after G. So the time will be 0.225 seconds and 0.525 seconds. So this is answer for A part 1. In part 2, determine for this oscillation the angular frequency omega. We must know that to find omega, we must know the frequency or the period. From your graph in figure 4.2, we can get two things. We can get the period, which is 0.3 seconds. You also know the amplitude, which is 2 centimeters. Of course, we don't need the amplitude here. So once you know the frequency, once you know the period, you can find the frequency, which is 1 over 0.3. Then omega can be found either by using 2 pi f or 2 pi over t, which will give you 20.9 radian per second. Then in part 3, you have to show that the maximum speed of the mass is 0.42 meters per second. The formula for maximum speed is A times omega, where A is amplitude, omega is the angular velocity. We know the amplitude is 2 centimeters, convert to meter is 2 times 10 minus 2 meters, and then your omega is 20.9, which you calculated from here. So when you multiply the two together, you get 0.42 meters per second. Use data from figure 4.2 and A part 3 to sketch on the axis on figure 4.3 the variation with displacement x from the equilibrium position of the velocity v of the mass. The graph is this one. You need to know that at A, the velocity is 0. But the displacement is maximum, amplitude maximum at 2 centimeters. At B, the velocity is 0.42 meters per second moving upward. And then the displacement is 0. At C, the velocity is 0 meters per second, meaning the object is stationary, and the displacement is minus 2 centimeters. And then at D, the velocity is minus 0.42 meters per second, meaning the object is moving downwards and the displacement is 0 centimeter.